Hello and welcome. You can see my board already. A few more integrals and questions involving the gamma function, which I have introduced. I've done some preliminary work, and I've done similar work, I think, on a previous lecture. This is probably the second lecture that has like this kind of integrations. And I wrote some of the special results for this particular integral function. Is definition, that's the definition of the gamma function. The recurrence relation that often comes in evaluations. This is if it's an integer, the gamma of n plus 1 is the same as n factorial for integer values of n. And the special result, the gamma of a half is the square root of pi, which I have actually spent time proving that result separately. So I have three questions to do today. They're very quick. They're not really long or anything complicated. The integral from 0 to infinity, I'm looking at the first question on my screen, to square root of x e to the minus x squared dx. And the question says, by using techniques involving the gamma function, find the exact value of that. Give the answer in the form gamma of k, where k is a rational number. There's some hair from my cat there. K is a rational number. K belongs to, forgot how to write rationals. Wow. Okay, k belong to q. All right. This is, try to match it with that. We need a minus t there, and t is a good substitution. So we're going to say, you know what, t is equal to x squared. Dt is equal to 2x dx. Getting my substitution ready. Dx is dt over 2x. So we're checking the limits next. What happens to the limits? When x is 0, t is also 0. So 0 maps to 0. And when x is infinite in the integral, so is t. So infinity maps to infinity. So for this particular one, there's no need to change anything as far as limits are concerned. I'm going to write this as 2x to the half. I'm not doing anything with that yet. To the minus t, and my dt in this particular case is, my dx rather, is dt over 2x, which will simplify to not to infinity. The 2's cancel, and I'm going to have x to the power of minus a half e to the minus t dt. And now here focus is very easy to say that's the gamma of half. Is not, because this is x and this is t. We need to have the same variables. So we need to go back here and get some stuff. Well, x is t to the half, and therefore x to the minus a half is t to the half all to the minus a half. So x to the minus a half is t to the minus a quarter. So we got another line to put in, t to the minus a quarter, e to the minus t dt. And if we compare with this, I'll put an extra bit just for fun. We can write it as, t, and I can write 3/4 minus 1. So that's to make up the minus 1 in the standard formula and still give us a minus a quarter, e to the minus t dt. And this is now by definition. You should be able to see it without writing this stupid thing. Probably that's more confusing than helpful. So that's the gamma, in fact, of 3/4. So your k is actually equal to 3/4. And this is the question done. It's not anything complicated. Just a reminder of the definition of the gamma function and a lot of substitutions. Try to get to the correct form. So we're going to go next into the second question of this video. By using techniques involving the gamma function, find the exact value of this integral, not to infinity, x to the 6 e to the minus 4x squared. And again, this needs to go into a single variable, dx. And they want us to give us the answer in the form k square root of pi, where k again is a rational constant. Okay. So to get the root pi there, clearly there's going to be a gamma of a half somewhere in this question. we're going to use a substitution. We need there a t for this bit here. So t is 4x squared. dt is equal to 8x dx, which means my dx is dt over 8x. Limits next. x0, t0. So 0 maps to 0. And if x is infinite, so is t. So infinity to infinity. Again, this question is very gentle with the limits. So x to the 6, we'll sort that out afterwards. E to the minus t, and then we have dt over 8x, which we'll do a couple of things. 1/8 pulled outside the integral from there, and then we got x to the 5, e to the minus t. Careful again. Mistakes do happen because people there see the gamma of 6, which of course it isn't, because this has to be a t in there. So I want to go back and say, you know what, x squared, looking at this line here, is a quarter of t. We need x, let's do it in steps. X is of course the square root of that, positive square root of that. So that's square root of a quarter is a half, t to the half, and then of course x to the 5 is that to the power of 5, which is 1 over 32, and is t to the 5 over 2. So this will now transform to 1/8. The x to the 5 is, I should have really written it on the outside, it's too late now, t to the 5 over 2, e to the minus t, dt. 32 times 8 is 256. Oops, forgot the limits. And that, of course, is 0 to infinity. And we now got t to the 5 over 2, e to the minus t, dt, which is, of course, by definition, I'm not writing this minus 1. I regret doing it on the last question, more confusing. Is one more from this quantity here, so long as we have the right format. So that's the gamma of 7 over 2. And now we're using the recurrence relation. So 1 over 256. And this bit here is 5 over 2 times the gamma of 5 over 2. Which of course will give us 5 over 512 gamma of 5 over 2. And again, we're using the recurrence relation. So the gamma of 5 over 2 is of course 3 over 2 times the gamma of 3 over 2. Using, of course, relation number 2 again, which is going to give us 15 over 1024, the gamma of 3 over 2. And I think on the next reduction, we're going to give us the gamma over half, and the question will be done. And the gamma of 3 over 2 is a half, gamma over half, and of course this will give us 15. 2048, that's this bit here, and of course the gamma over half is the standard result, is root pi. And this is the question. Of course your k in this particular case was ugly, 15 over 2048. Was it hard? No, it's just the same old kind of thing. Okay, let's, that's the second question that I'm going to do. I plan to, just so we have a video of kind of like sensible length. Otherwise there'll be too many videos. They'll be short, but too many of them. Let's go for the third and final question. This will be different in terms of techniques in integration. By using techniques involving the gamma function, find the exact value of this integral. Let's write it down. 0 to 1 log of 1 over x to the power of a minus 1. I'm already making a mistake here. If I put it here, it means different. It's the whole log that is to the power of a minus 1 dx, where your a cannot be 1, 0, minus 1, minus 2, minus 3. Give the answer in terms of a gamma function. So there'll be a function of a quite clearly. because of that A that's in there. This, I haven't got a clue where to start at first glance. So of course I have a clue, it's just that I'm trying to think what I'm going to do. My first, I'm playing around with it. I'm going to say T is the log of 1 over X and hope for the best. So that's going to be T to the A minus 1. So I'm kind of like maybe creating this bit here. I'm not quite sure what I'm doing, if I'm going to be entirely honest with you. Actually, no, I can say what I need to do now. This, in order to get, I need to get rid of the log, so I need to E both sides. So in fact, this is going to be that, but I need a minus, and I'm going to get a minus very easily by writing this as minus log of X there. So I wrote the X to the minus 1, then moved it to the front, and then of course I can have a minus T is equal to the log of X. Okay. Where do we go from there? We're differentiating, of course, but before we differentiate, probably it's better to E both sides, so we can create that and differentiate from that particular line. So e to the minus t is just simply x. And now my dx is going to be minus e to the minus t dt. And let's see what happens to the limits. And if I need extra stuff in there, because I don't know if I need extra bits. So when x is equal to 0, so I'm looking at the lower limit, x is equal to 0. 1 divided by 0 is infinite. The log of infinity is in fact maps to infinity. Slow, but it does go there. When we put in 1, we have the log of 1. So 1 maps to 0. So this particular integral will go 0 goes to infinity and 1 goes to 0. So we have the limits the wrong way around. The log of 1 over x is just simply t. That's t there to the power of a minus 1. And the dx, the dx is going to be minus e to the minus t dt. And this is actually very easy now. Firstly, this minus swaps the limits to the required form. And we have t to the a minus 1, e to the minus t, which is just a gamma definition. If you look at the definition, it's exactly the same thing. It's just the x is replaced by a. So this, in fact, is the gamma of a. Okay, and I don't think there's anything else to do with this particular question. I went a little bit fast, and I hope you follow what I've done. And I will try to be putting at regular intervals, so long as I'm around, still more questions. I might start Fourier series soon. I'm just trying to give you enough of one topic before I jump to the other one. And before, obviously, we go to Fourier, maybe we're going to do a bit of beta function, or I might stick to start the Fourier and then start the beta functions after that. Okay, I'm going to be signing out. I hope you enjoyed it. I'll see you real soon. Bye for now.